Welcome to AKB Guidance. Today our topic is factors, forces, processes influencing Earth's surfaces. So today the Earth what we are seeing has undergone many of the changes and has formed the Earth to which we are seeing today. So first let's discuss the minor factors which influence the formation of Earth. Then we'll go in detail about the major factors. That is the main topic of our today's lecture. And first we'll see what are the minor factors that affected the formation of Earth. So minor factors. This lecture may take long, but you should patiently watch this video to get your doubts clarified. So what are the minor factors? The first minor factor is density. We know that Earth is classified into number of layers and each layer has different density, which helps in formation of the slopes, the reliefs on the earth surfaces. Like I can say, in we can take the case of volcanoes. Here, volcano. What does volcano do is the plate which is having higher density will get subducted, and the plate which is having lower density will float on the density having higher. So the next minor factor is friability. That means ability of rock to crumble easily, break easily, ability of rock to break easily. And the next is hardness of rock. Then the fourth one is composition. The what is a layer composed of, like iron, fer and silicon. Different kinds of metals and minerals are composed, which forms a minor factor for influencing the Earth's formation. Next is permeability. What does permeability means? The ability of soil or rock which allows water to sink in it. This is permeability. And the other is porosity. Porosity is nothing but a kind of a rock which has small holes on it. This is called porosity. That means it is porous. And the next minor factor is folds. This will discuss in detail. And the other is faults. This also will discuss in detail later. And the other granular size, crystal size, relief topography, and stage. That means different kind of stages it has undergone. And climate is also a factor. Majorly climate affects in breakdown of rocks, and of course time. time is the major factor because the earth has undergone different kind of changes since billions of years and has formed into the shape which we are seeing today. So these are the some of minor factors which affected or influenced the formation of earth. So now what we are going to do is we'll see the major factors which affected the formation of earth and major factors. I'll try as possible as speed as possible, but I don't know what will happen. So the first is it is classified into two types, endogenetic and exogenetic. We'll discuss each and every topic in detail, but you should be in patience. I think this might take a lot of time for us to write and explain. So what I will do is I will go into the PDF which I have made. So that will make our work easy. So this is the my handwritten notes which I have made. I will share these notes with you and the factors, forces and processes influencing the earth's surfaces. These are major factors. The first is the endogenetic and the second is the exogenetic. Let's say endogenetic first. Endogenetic is roughly classified into diastrophic and sudden forces. And in diastrophic, it is classified as epirogenetic and orogenetic. Sudden forces are volcanic forces and earthquakes. And epirogenetic is also classified into two kinds, emergence and submergence. This orogenetic force is classified as two types, tensional and compressional. Tensional force is also further classified as faulting and cracking, and compressional is classified into crustal bending and folding. Don't worry, guys, we'll discuss each and every topic in detail. And now the exogenous forces is classified into weathering and gradation. Gradation is further classified as degradation, aggradation, and transport. So what we'll do is we'll discuss each the topic which I have shown in a flow chart. Each topic will take in separate and we'll discuss in little detail. So the father of geomorphology, what he said was, he is William Davis. He said endogenetic forces are variability developers. That means endogenetic forces, consider this as a earth. Endogenetic forces means the forces which are coming within the earth, from inside the earth. This is endogenetic forces. These forces are the base for development of reliefs like mountains, or they may form some depressions like we can say here sea, water. This depression is formed into sea or ocean. And next what he said is exogenic forces are the levelers. These are the external forces which help in leveling the surface of the land. So see these mountains, due to some gravitational forces or water or some other minor factors which you have seen, that affects the relief, and that breakdowns the relief parts, and it breaks into granular forms, and slowly, with the help of gravity or water or air, this comes down and settles in the slope area. So this is exogenetic forces forms as levelers, which helps in leveling the earth's surface. Now the first topic from here, we'll take exogenetic forces and we'll discuss about gradation. Gradation is a continuous leveling process which therefore include two types. It is a leveling process which I have said here. It is a leveling process which helps in making land surface, in flat or some rough kind of area, which helps in leveling the land surface. And this gradation is classified as degradation, aggradation, and transportation. Degradation is simply nothing but cutting down the elevated feature, which I have said here. This is the elevated feature. This degradation helps in cutting this portion, or some, it helps in cutting these granules from this relief, and it helps in bringing them down. This is degradation. Now we'll see aggradation. Aggradation is deposition filling up natural depression. See, this is degradation which helps in deforming the rocks. And next comes in picture is aggradation. If this is a depression, this is the aggradation relief. Due to degradation, this part gets degraded or eroded, and due to aggradation, this comes and settle here, or with the help of air, gravity, this comes to this depression, and this starts settling here. Now what happened is the sea surface or the depression slowly got compressed, that means slowly decreased. This helps in leveling the surface area, that is aggradation. Now we'll see what is transportation, that I have discussed here. This air or gravity plays as a role of transportation, which helps in transporting this degraded material to aggraded area. This is helps in transporting. So this is called transportation. Now we have seen what is gradation, and gradation classified into degradation, aggradation, and transportation. I hope till now you have got everything. And next we'll see gradation is carried out by 5 different agents, that is running water, glaciers, wind, sea waves, and underground water. This we also call as transporters, which helps in transporting the degraded materials. And then next comes weathering. Weathering is basically a mechanical disintegration process, or it may be chemical decomposition. See, this is a relief. This is the relief due to mechanical forces, like what we have discussed here. These are winds, water, or some anthropogenic also. It is man-made effects, and some chemical decompositions such as, say, due to fauna. sorry, due to fungi, like I can say plants. Here we'll see different kinds of plants are grown on mountains or rocks, different kinds of plants which grows in these reliefs. So what these plants do is they start growing their roots deep inside this mountain or this rock, due to which the rock gets weakened and the roots get seeped into the rock, and the rocks get weakened and starts breaking. So this acts as a chemical, sorry, not, this is not chemical, this is mechanical, not chemical, this is mechanical. So we'll talk now about chemical. Chemical is I can say salts. Rock contains salts or water contains salts, which uh, this is affected by temperature. So during summer, the rock gets expanded, and due to cold, the now we'll see chemical decomposition. Chemical decomposition is nothing but, I can say, rusting. That is, rock contains ferrous metals, which due to oxidation or which comes in contact with water, rust get formed in the rock, and this helps in weathering, or we can say degrading the rocks, and further the process continues. So other like weather and climate also plays a role, which I have discussed here. So we'll see a example for climate and weather. See, let us consider a rock. Let us consider this as a rock. Now what happened is, due to during summer, what happens, due to heat, the rock gets expanded, and when it comes to winter, the rock gets compressed again, due to which there is contraction and expansion takes place, and the rock gets deformed, and there is a chance of breakage. Upper layer gets breaked, and it forms weathering. It is also a kind of weathering due to climatic factors. So now we have seen what is weathering. Now we'll get into other topic, mass wasting. Mass wasting is nothing but, consider this relief. Now what happened is, due to some glacial activity, or due to any kind of weathering, this rock gets into granules, breaks into granules, and with the help of gravity, this comes to the surface. So this is coming down with the help of gravity, and here not only comes one single part, but it brings many small pieces with it. So this is called mass and which brings down is called wasting. So we'll see what they have given definition. Gravity transforms of broken rock materials. This process is distinguished largely on basis of texture of mass wasting material. See, this is the important point. You have to make a note of it. Weathering is not prerequisite for mass movement, though it aids mass movement. So what he is saying is weathering. Now earlier we have seen what is weathering. So weathering is not a prerequisite, that is not required for mass wasting, but it helps in making the process speed. So it makes the process very easy for mass wasting. So next, mass movements are very active over weathered slope rather than unweathered slope. This is a point which we have discussed now. Very active. That means they come rapidly down to the slopes. Flow. Flow is classified into creep, solidification, and avalanche, and slide slumps. These are what we have discussed here. If the rock slowly creeps down, we call it as creep. And when it gets avalanche, means when ice particles brings the rock materials or the particles with it, granules with it, then it called as avalanches. And due to some anthropogenic causes, the land gets slided, so that we call as a landslide. So these are, we can say, these examples comes from here. So next we'll go to diastrophic. What is diastrophic? Diastrophism, it is a slow process. Diastrophism is a slow process that takes millions of years to register development of recognizable modification on Earth's surface. This takes millions of years to get recognizable, and it includes epigenetic and orogenic forces. What I have discussed earlier is, see, this is the earth what we are seeing today. It have undergone many changes, like it had a say, it includes epirogenic and orogenic forces. So now we'll discuss what is epirogenic forces. And see, we have classified epiros one and orogenic other part. Epiros means continent and gnesis means origin. It is a continent building process which represents vertical force, that is upward force or downward. And we have seen that epirogenic is classified into two types, that is upward movement and downward movement. So upward upliftment of whole continent or part of it, that is called emergence. See, due to some forces, the part of earth gets uplifted. This you consider land, and this continent, and this is also continent. So this part gets uplifted due to, let us consider compression. Due to compression, this part gets uplifted. So the upliftment of whole part of continent or part of it is called upward movement, or here it is emerged as a fold mountain, so we call it as emergence. Simply we call it as emergence. And downward movement or submergence. Downward movement is, let us consider this is a continent, full of continent. Due to some tensional forces or divergent forces, this gets breakdown, and this breakdown part sinks down. Wait. So this part got breaked, and now it emerged. Now here it emerges sea water forms here, and sea emerges here. Sorry. Land is submerged here. Or we can consider other example. Now, recent example will take due to climate change. The glaciers are getting melted, and we are seeing the continent are getting submerged with water, or some islands have diminished due to the flow of water, that may increase of water. So this is called submergence. This land gets submerged under the water. So this is the submergence. Now we'll see what is the orogenic force. We'll quickly finish because it's getting very late. Orogenic force. Oro means mountains and gnesis means origin. It represents horizontal force and facilitate vertical elevated feature. See what we have discussed here. It is a horizontal force. Let us consider this as a continent, and due to compressional forces, what happens here is, if consider this as a weak zone, then from here a kind of fold generates and it forms into a fold mountain. So this is a vertical force acting here, and it is forming an elevated feature. This is the elevated feature. So this is the horizontal force acting here, and the landform gets elevated. So this is the orogenic force. And horizontal force is also called tangential force. It is distinguished as tensional and compressional. What I have discussed, this is the compressional. Tensional is quite opposite, to opposite sides. We'll discuss in detail. So tensional force, it operates in opposite direction, also called divergent forces. What I have discussed earlier, it creates rupture, crack, fracture, and faults. So let us consider this is a continent, and sorry, this is the continent. This is the stage 1. This is the continent, and in stage 2 what happens is, due to some kind of cracks or some kind of weak zone here, and due to the tensional force acting here, tensional force acting here, this get diverged, and what forms here is, later it forms as this, and water gets filled in this area, and it forms as lake or sea, etc. Water filled with this. So this creates rupture into the land surface, or and it forms cracks, fractures, and faults. This is called a fault. And next we'll discuss the compressional force. Compressional force operates face to face. That means in same direction. It also called as convergent force. Causes crustal bending, leading to formation of folds and crustal wrapping, which I have discussed earlier. I think you may understand this easily. So next we'll go to the crustal bending. Crustal bending results into formation of plateaus. Example is the Tibetan Plateau has been formed due to bending of Eurasian Plateau, and it affects large scale area. There is nothing more in this topic. You can easily understand it, and we'll discuss what is folding. Waves, waves like bends are formed in crustal rocks due to tangential compressive force. Say this is the continent. Let us consider this is the continent, and due to compressional force acting on two limbs, these are called limbs. These are called limbs. On both the sides of limbs, compressional force is acting here, and due to which this gets compressed, and it forms in a curve. It forms into a curve. So this is what they are explaining, and this in a longer period of time forms into a wave. So wave-like bends are formed in the crustal rocks due to tangential compressive force. So the plane which bisects the axis between two limbs is called axis of fold or axial plane. So this is called axis or axial plane. Exactly in the center of the plane is called axial plane. And now we'll discuss what is anticlines and what is the syncline. I hope you are getting till now what we have discussed, and we'll see what is anticline and what is syncline. It is easy, not so difficult to understand. And see, let us consider this as a fold mountain. So what happened here is this upper part is called anticline and this lower part is called syncline. As simple as that. So see, upfold rock beds. This is upper upfold. Upfold rock beds is called anticlines. When the slopes of both limbs of an anticline are uniform, it is symmetrical anticline. And when slopes are unequal, it is called asymmetrical anticline. That means if the slope is equal, then it is called symmetrical. If the slope is not equal, then it is called asymmetrical. As simple as that. And synclines. Synclines are downfolded rock beds. That means if you consider this is called syncline. And now what? Now we'll see what is antisynclinorium. Antisynclinorium. This is nothing but I think I had a graph of. See, many anticlines and synclines are formed into another anticline and syncline, that is bigger anticline and syncline. This is called antisynclinorium. Did you get this? And the best example for this is Blue Ridge of anticlinorium in Virginia. And synclinorium, this is the anticlinorium and this is synclinorium. And the synclinorium is the best example, Kathmandu Valley. Next, we'll discuss types of folds. Folds are generally classified as different kinds. and we'll discuss some major kinds of folds here. So I think we have discussed the symmetrical fold in earlier part. Now it will be easy for you to understand. Similar uniform angle axial plane is vertical. See, by this figure you will get all the kinds of folds as into clear picture. This is the axis plane which divides two planes into half, and uniform angles, this angle and this angle is same. This is called symmetrical. And asymmetrical is, this is the plane axis. Here we are having a angle and here we are having B angle. That means both are different angles. That is called anti-symmetrical, asymmetrical. So the best examples for symmetrical folds are Western Cordillera. Now I think you are getting doubt about what is Cordillera. Cordillera is a simple term, that is a chain of mountains, which I have explained here. This is the chain of North American and South American mountains, or we can consider our Himalayan mountains as Cordillera. So this is the Andean Cordillera of South America and Western Cordillera of North America. Asymmetrical folds. Axial planes is inclined or inclined different angles, which we have discussed here. So I think you understood what is asymmetrical fold, and examples are Himalayan Cordillera and Alpine Cordillera. Then monoclinal folds. One limb inclines with a regular slope while the other limb inclines with a right angle. See, consider this is one limb. Sorry, let me draw for you again. See, this is the regular angle and this makes a 90 degrees angle. So this is the 90 degrees angle. That is what called as monoclinal folds. Example, Colorado Plateau and isoclinal folds. The next type is the isoclinal folds. Both the limbs of the fold becomes parallel but not horizontal. See, both the will get into the figure so you can get it easily. Both the limbs are in parallel but not exactly horizontal. Okay, this is called isoclinal folds. Example, Himachal range and of Himalayan Cordillera. And recumbent folds. Fold becomes parallel as well as horizontal. See, fold becomes parallel as well as horizontal. See, this became parallel as well as it is in a horizontal direction. That is called recumbent folds. Example, Dinaric Alps of South Europe and Darjeeling Hills. And overturned folds. Overturned folds is nothing but we'll see folds are overturned too much. Sorry, folds overturned too much. So that is called as overturned folds, or we can say like this. You can see here the fold gets overturned. So one limb of the fold is thrust upon the another fold. Limbs are seldom horizontal. They are not rarely horizontal, but one limb will put more pressure on the other limb, and which passes through the other limb. So this is the overturned folds. And next is the napis. It is defined as broken fold that is developed when a inducted compressional stress surpasses ductile characteristics of rock resulting into breaking. This is simple. See, we have example also. This is the Nanga Parbat area and this is the Namcha Badwa. What happens here is, consider this as a fold due to extreme compressional force. Here we will see a breakage. Here there will be a breakage and it forms into nappies. So this is called nappies. And the other is the fan folds. Fan folds is comprised of antisynclinorium and synclinorium. This is nothing but what we have seen earlier, and the entire part of antisynclinorium and synclinorium is called fan folds. And Chevan folds, Chevan, Chevan fold. Chevan fold is nothing but more structurally regulated. That means it may have a regular structure like this what we are seeing here. So it will have regular structure, not irregular, like it will not have this kind of irregular structure. It will have regular structure, steep slopes, like smooth surfaces, etc. And what is the open folds? Open fold, angle between two limbs of the fold is more than 90 degrees and less than 180 degrees. See here, this is the fold and the angle between them is greater than 90 and less than 180. So this is called open fold. And closed fold is angle between two limbs fold is acute angle, that is less than 90 degrees, less than 90 degrees, that is the closed fold. Now we'll get into faulting caused when tensional forces are intense, and a fault is a fracture which involves appreciable displacement of rocks on both sides of the fracture and parallel to it. So tensional, due to tensional force, faulting takes place, which I have discussed earlier. You might be having some kind of idea now. So faulting due to tensional forces. See, due to tensional forces, what happens here is there is a slight breakage of a continent, and one part moves down and other parts floats up. So this is called faulting. And faults are classified into two types, like normal fault, reverse fault. So first we'll say what is normal fault. Caused due to tensional force, displacement of both rock blocks in opposite direction. The scrap is steep. This is the scrap, this is the steep, and the block which comes upward is up throw, and the block which goes below is, we call it as down throw. And the distance between these two joints, or we can say these two blocks, is, we call it as heave. And this is the fault plane. This is the fault plane. So this is the normal fault. And the reverse fault, here what happens is the block makes a kind of angle and it gets uplifted. Due to the compressional forces, the movement of both the fractional rocks towards each other. In reverse faulting, there is a shortening of faulted area. See, there is a shortening of faulted area. Here, due to compressional force, due to compressional force. So mainly this is acts on compressional force, due to compressional force. And transform fault, we can say two blocks get transformed in opposite direction. This is called transform fault. When forces are acting parallel to each other but opposite in direction. See, forces are acting in parallel but in opposite direction. Example, St. Andreas Fall of California. Next, the Rift Valley or Graben. This is a simple thing which I have explained you many times. Long, narrow troughs, depressions, or basin between two crustal parts. Simple graben. Simple graben is nothing but this part gets subtracted down, and simple host nothing but due to this is initially due to I can say tensional force, and this is due to compressional force. Simple host is formed due to compressional force, and a simple graben is formed due to crustal force. That's all, guys. I think we might have taken long time for this lecture. Hope all your doubts got clarified, and I think you may share to your friends who are in need, and will be regularly uh, making videos on geography optional, and after completion of optional we'll start the regular subjects, general study subjects. So first we'll finish geography, or we can say geography optional, then we'll start general studies. So keep watching, and please share and subscribe. Thank you.